What's up, brilliant minds? Welcome to Mind Loom Labs, the channel where we don't just learn, we grow our minds. If this is your first time here, hit that subscribe button because we're all about making complex topics simple, exciting, and actually fun. Today we're going to explore one of the most fundamental concepts in digital electronics and computer science, logic gates. These tiny but powerful components are the building blocks of all digital circuits, from your smartphone to the most powerful supercomputers. Think of logic gates as simple decision makers. They take one or more inputs, process them according to specific rules, and then produce a single output. And they do all of this using binary values: 0, which represents false or off, and 1, which represents true or on. So what exactly are logic gates? They are basically tiny electronic circuits that perform logical operations based on a branch of mathematics called Boolean algebra, named after the brilliant mathematician George Boole. Each type of gate has its own unique behavior, which we can map out using something called a truth table. A truth table is just a simple chart that shows every possible input combination and the output that results. Ready to dive in? Let's explore the main types of logic gates. First up, we have the AND gate. Imagine a D-shaped symbol with a flat input side. The rule for an AND gate is simple. The output is 1, or true, only when all of its inputs are 1. Think of it like a door that requires two different keys to open. You need both key A and key B to be present and turn for the door to unlock. If only one key is there, or neither, the door stays shut. Next, we have the OR gate. This one is shaped like a pointed shield with a curved input side. Its rule is that the output is 1, or true, when at least one of the inputs is 1. A great real-world example is a room with two light switches controlling the same light. You can flip either switch to turn the light on. As long as one switch is in the on position, the light will shine. Then there's the NOT gate, also known as an inverter. It looks like a triangle with a small circle at its tip. This one's super straightforward. Its output is always the opposite of its input. If you give it a 1, it outputs a 0. If you give it a 0, it outputs a 1. It's like a push button that works backwards. When the light is on, you press it to turn it off, and when it's off, you press it to turn it on. Now things get even more interesting with the NAND gate. The symbol is just an AND gate with that same little circle at the output. This circle means it's a NOT AND gate. Its rule is the exact opposite of the AND gate. The output is 0 or false, only when all of its inputs are 1. In all other cases, the output is 1. Here is a cool fact. NAND gates are called universal gates because you can actually build any other type of logic gate using only NAND gates. Similarly, we have the NOR gate. You guessed it, it's an OR gate with a circle at the output, meaning not OR. It does the opposite of an OR gate. The output is 1, or true, only when all of its inputs are 0. If even one input is a 1, the output becomes 0. Just like the NAND gate, the NOR gate is also a universal gate, making it incredibly versatile in circuit design. Let's move on to the XOR gate, which stands for exclusive OR. Its symbol looks like an OR gate, but with an extra curved line on the input side. The rule here is that the output is 1, or true, only when the inputs are different. So, if one input is 0 and the other is 1, the output is 1. But if both inputs are the same, either both zeros or both 1s, the output is 0. Think of a two-way light switch in a hallway. Flipping either switch changes the light state, but if you flip both at once, it's like you did nothing. Finally, we have the XNOR gate, or exclusive NOR. It's an XOR gate with that little circle at the end. It's the opposite of XOR, meaning its output is 1, or true, only when the inputs are the same. If both inputs are 0, or both are 1, the output is 1. If the inputs are different, the output is 0. You can think of it as a match checker. It gives you a true signal only when both inputs are identical. So, let's do a quick recap. We have the AND gate, which needs all inputs to be true. The OR gate, which needs at least one input to be true. The NOT gate, which flips the input. The NAND and NOR gates, which are universal and are the opposites of AND and OR. And finally, the XOR and XNOR gates, which check if inputs are different or the same. So why is all of this so important? Because these simple gates are the absolute foundation of all digital technology. They are combined in incredibly complex ways, with millions or even billions of them working together to create everything from computer processors and memory chips to calculators and the circuits inside your smartphone. Every single digital device you use is powered by these logical decisions happening at lightning speed. Understanding logic gates is your first real step toward understanding how computers actually think and process information. Thank you for learning with MindLoom Labs today. If this video helped you understand tech a little better, please give it a like and subscribe to support the channel. Remember, the future is digital, and you're already part of it. See you in our next lesson.